Hi, so this video is a quick discussion about electrodeposition, and electropolymerization and electroplating. Now, electrodeposition means generally in the liquid phase you have a conductive surface, and in the liquid you have some atoms or molecules, and those atoms and molecules are mostly happy to be in that solution until you apply something like a voltage or pass a current. So you effectively put electrical energy. So in this, I'll say like we apply a positive voltage maybe to that electrode, at which point then these ions, or it's not these ions, but these atoms and molecules, they start going towards the surface, and they effectively start depositing on the surface. So in general terms, electrodeposition is the encouragement of molecules or atoms to absorb onto a surface from the liquid phase by the application of a voltage or maybe passing a current. So that's sort of generally electrodeposition. Now, people often use the word electrodeposition when they're actually having a more specific example, which is electroplating. So electroplating, I think, is a more accurate description of a subset of electrodeposition. And electroplating, again, you have your conductive surface. Now, in electroplating, we're often talking about metal electroplating. So you actually have a salt or a cation which is positively charged. The kind of examples are copper 2 plus, maybe nickel 2 plus, gold, I think gold is maybe 3 plus. And what's happening is now you're either applying a negative voltage or applying a current out of the electrode. So what's happening is we put a negative voltage on the metal. These ions reach the surface, and what's happening is when they reach the surface, their positive charge is then receiving an electron. An electron is effectively leaving the surface, and the positive is getting an electron, and it actually forms a sort of neutral metal atom. So as opposed to having a metal salt in the solution, the positive ion reaches the electrode. We're applying a negative potential or passing a sort of negative current, and the cation or the salt is receiving electrons, at which point it's forming the atom, and then you start to get a deposition, or plating I should say, of these metal atoms, and you get a electroplating. Now, the term electrodeposition can also mean another process, which is electropolymerization. So in electropolymerization, you, for example, would have again a conductive surface, and what would be happening is you would have maybe a organic molecule which is happy in solution, but what happens is you apply maybe a positive potential, and these molecules, when they get close to the surface, they now lose an electron. So an electron goes to the metal and basically goes into a circuit, but what it leaves behind now is it's called a cation radical. So it's a positively charged organic molecule with a unpaired electron, and this is like the key words here, sort of free radical polymerization. What happens is these cation radicals can react with other organic molecules, and they start polymerizing. So they all start sharing electrons. So now, rather than being individual monomers, you end up with a polymer. And you end up with a polymer often on the surface because you're forming these cation radicals near the surface. So they end up coating the surface. So now we have electropolymerization. So electrodeposition is a sort of general term for the coating of conductive surfaces. But then under that there's a subset which I would call electroplating. And electroplating often means the coating of metal surfaces or conducting surfaces which are held at a sort of negative potential. The metal ions come along, they receive an electron, and now you start getting a new coating of metal on the electrode. So that's electroplating. And then the other sort of subsection of electrodeposition is electropolymerization, where you may have a conductive surface in contact with a solution of organic molecules, and everyone's happy until you apply a positive voltage, maybe as an example. The positive voltage causes a loss of electron from one of these organic molecules. So an electron is lost. I'll show it here as well. And an electron is lost, at which point now you form what's called radical cations. Near the surface, and these radical cations react with other Rs or other organic molecules, and you end up polymerizing what were otherwise monomers, but you end up polymerizing them very close and on the surface. So that's electropolymerization. Right, so in summary, electrodeposition actually means really just means the sort of modification of surface by the application of voltage or current on a conductive surface. And under that there's a subsection, there's electroplating and electropolymerization, and then there are other processes as well. Okay, I hope that helps.